In this video, we are going to discuss the difference between a relation and a function. A function is a type of relation. So a function can never not be a relation. It is a relation. It's just a specific type of relation. A function is a relation in which each element in its domain has only one element in the range. So what that means is if you have a number in the domain, it can't have two or more elements in the range. So if we have items listed in the domain, let's throw an example up here. So we have 1, 2, 2, 3, need my parentheses, and 1, 3. So this one would not be a function because this number in the domain has two different items that are related to it in the range. That cannot happen. It's like saying if we're solving for an equation, we would have to try to figure out what the other y value for x would be, and that can't happen in a function. So let's take a look at these examples and see if we can determine whether it's a relation, whether the relation is a function. They're all relations, we have to determine if they're functions. So what we're looking for is to see if the same item is in the domain more than once, because that means that it's assigned to more than one item in the range. So we have -3, -2, -1, 0, 1, 2, and 3. These are all distinct numbers. So all of the numbers in the domain are all different. So this one is a function. Look at number 2. We have 9, 4, 1, 0, 1, 2, 1, 4, and 9. This one is not a function. 9 shows up twice. It's related to -3 and +3. 4 shows up twice. It's related to -2 and +2. 1 shows up twice. It's related to -1 and +1. So this is not a function. So when you see ordered pairs as your relation, it's pretty easy to determine if it's a function. If the number in the domain shows up more than once in the ordered pairs, you know that it's not a function. But you do have to make sure that the number in the range that relates to the number in the domain is actually different. So if a relation showed 9 and -3 and 9 and -3 twice, that's perfectly okay. It's still a function. It's just they listed the ordered pair twice. But if it has a different number in the range, then it's definitely not a function. So pause the video here, work on problem 16. Hopefully my hints will make it so that it won't take you too long. All right, let's move right along. Problem 17. Determine whether each equation is a function. So this is kind of a guess and check type scenario where you have to figure out, what is my range? What is my domain? So what is our domain in this function? Is there anything in the domain that any number that we can't put in for x? No, it's all real numbers. The range, is there anything that we cannot get out for y? No, it's all real numbers. Well, that's not very helpful, is it? So let's test some stuff out. This is going to be one of those scenarios where I will say, draw a t-table. What we're going to do to test this out is we're going to put in values for x, values for y. We'll put in a positive value for x, let's say 3. We'll put in a negative value for x, let's say -1. Put in 0 for x. Now, I will also recommend put in a really, really, really big number for x, like let's say 1,000. You could say a million. I just don't want to write that many zeros. You could put in a fraction for x, 1 over 100. You could try a negative really big number and a negative small number. Let's see what we get. Put 3 in for x, we get 2 times 3 plus y equals 7. This is 6. Subtract 6 from both sides, we get y equals 1. Negative 1 times 2 plus y equals 7. Negative 3 plus y equals 7. Y equals 10. Put 0 in for x, that just disappears. All we get is y equals 7. What if we put 1,000 in for x? Get 2,000 plus y equals 7. Y equals negative 1993. Put in 1/100th. You'll get 2 over 100 plus y equals 7. Y equals 6 and 98 hundredths. So it's really close to 7. Put in a negative 1,000 in there. So that's like negative 1993 and 2/100ths. Oh gosh. Nope, I mixed that up. Apologies. This is why we draw lines where we're doing our work, where we're doing our t-table. That is simply 6 and 98 over 100. I'm not going to worry about reducing the fraction. We're just trying to figure out if this is a function, if there are any x values that would create more than one y value. Negative 1,000. Let's see, that would be negative 2,000 plus y equals 7. Y equals 2,007. We put in negative 100, this would just turn into a negative, and we get 7 and 2/100ths. Looking at this, nothing is overlapping, so I'm going to say that this is a function. How about y equals x squared plus 1? X squared, let's do positive, negative, all that fun stuff. Oh, that is not a very good line. I'm going to do my t-table on this side. I'm going to do it in a different color. I'm just going to do 100 and 1/10. So 3 squared plus 1, 9 plus 1, y equals 10. Y equals negative 1 squared, which is positive 1, plus 1 is 2. X is 0, that makes that go away, so y equals 1. Y equals 100 squared, that'd be 10,000 plus 1, be 10,001. X squared being 1/10 would be 1/100th, plus 1 is 1 and 1/100th. Negative 100 squared is 10,000, plus 1 is 10,001. Now we see that we have repeated items in the range. That's okay. We just can't have repeated items in the domain. So we're all good still. Negative 10 squared, negative 1/10 squared is 1/100th, plus 1 is 1 over 1 and 1/100th. So I'm going to go ahead and say that this is also a function. How about the next one? Let's do a t-table. Do it over here this time. We have x, we have y. Put in a positive number, put in a negative number. Let's do 4, 0, negative 4. Let's do 100 again. 1/100th. Negative 100 and negative 1/100th. So let's stick 4 in for x. 4 plus y squared equals 3. Subtract 4 from both sides. Y squared equals negative 1. Well, this is not a valid item to have in our domain, which is fine. It just limits our domain because we can't take the square root of a negative 9. That is an imaginary number. Still could be a function. It just means that that number isn't in our domain. Let's try 0. So then we have y squared equals 3. Take the square root of both sides. Y equals... Now here's a problem. When we take the square root of both sides, it can be positive or negative square root of 3. So that's an issue. That is a big problem. So make sure that when you're taking the square root of both sides, you're doing your positive and negative. Don't forget your negative. This is telling us this is not a function. Because putting 0 in for x can yield us a positive negative 3 or a negative negative 3. That's two different items in our domain. Or I'm sorry, in our range. So that is bad. That is telling us this is not a function, it is simply a relation. Pause the video here, work on problem 18. See if you can come up with any patterns as to what you see are generally functions and what are not. All right, welcome back to the video. Now I'm going to show you a much easier way to tell if a function is a function or not. It's called the vertical line test. This is going to save you from having to create all of those crazy t-tables that I just tortured you with. Which you're saying, geez, you couldn't have told us that before we just spent up teen hours on the last few problems? Sorry, I needed you to understand how awesome the vertical line test is. So what the vertical line test is saying is if you have any set of points, a line is an infinite set of points going in all directions. This is a parabola, infinite set of points, or you could just have ordered pairs as points across the graph. When you have a set of points on your coordinate plane, if you draw a vertical line, a line going up and down at any point, at any time in that coordinate plane, if the line or if 2 points touch that line, it is not a function. So let's look at this first one. We have a straight line going this way. If we draw a vertical line going through all these points, no matter where we draw this vertical line, it's only going to hit 1 point. So this is a function. Let's look at problem B. Drawing vertical lines. Oh, we're not even hitting any points over here. We hit, whoa, no, we hit 2 points. We're hitting 2 points. This is not a function. We're hitting more than 1 point with our vertical lines. So, I mean, if we'd stop drawing our line right here, and it just hit that 1 point, that wouldn't be enough. You have to look at the entire graph and make sure there are no times where you wouldn't be hitting more than 1 point. So there's problem 20 with some more examples for you. Work through those. This should make life a lot easier for you. And going forward, if you see any functions, go ahead and graph them and use the vertical line test. Then you don't have to worry about doing a positive number, a negative number, a large positive number, a small positive number, large negative number, a large small negative number, and 0. That's like a lot of points to graph. You could just graph your equation, do the vertical line test going forward. Hope this helps, and I will see you next video.